One of the reasons we love Tesla and constantly keep an eye on the company's future plans is that you never quite know what's coming next. Everything seems to emerge unpredictably, and those products are bound to be unlike anything else on the market. Elon Musk always manages to do that. He aims to turn things people believe the company can't achieve into reality. It's just a matter of how fast or slow it happens. People are often convinced that Tesla only produces expensive electric vehicles to generate massive profits. Evidence of this lies in the fact that so far, Tesla's entire lineup starts at over $40,000, while the majority of customers demand vehicles priced under $30,000. We used to think that if Tesla were ever able to produce a car costing less than $30,000, it would be a distant story. 5 years ago, at a major Tesla event, Elon Musk mentioned a $25,000 car that would eventually be produced, but it clearly hasn't materialized. That's why it's hard to believe that an affordable Tesla vehicle will launch this June, the Tesla Model Q. It has been officially confirmed with a starting price of $30,000. Welcome to evtech. Before we begin, please help us reach 1,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla bots, Tesla EVs, and the latest news. Thank you. In our opinion, Tesla's launch of the Model Q seems to be a move that comes sooner than expected, as the company recognizes that affordability remains one of the main challenges for Tesla EVs to become widely used, especially in competitive markets like China and the United States. As evidenced by Tesla's 2024 revenue decline, so in order to not let 2025 become more disastrous, Tesla is forced to launch the car that the majority of customers are waiting for and do not hesitate a second longer to buy it. Or rather, the Tesla Model Q will save Tesla this year. Expected to launch in the first half of 2025 around June, the Tesla Model Q promises to revolutionize the affordable electric vehicle segment with an impressive starting price under $30,000, potentially even as low as $25,000. This marks Tesla's first entry into this segment, offering a broader opportunity for global customers to access electric vehicles. The official announcement about the Model Q was made during an investor meeting at Deutsche Bank, garnering significant attention from the EV industry. However, Model Q might not be the final name Elon Musk settles on. Previously referred to as Model 2, it seems likely that neither name was Tesla's definitive choice. With the internal codename Redwood, the Model Q is set to be compact and refined, measuring 15% smaller and 30% lighter than the Model 3. At just 3,988 millimeters in length, the Model Q will be a compact crossover with a much more minimalist design compared to the Model 3. Its standout feature will be a light bar reminiscent of the Cybercab, which launched last October. Tesla seems to be adopting this design language for all its future EV models. These minimalist designs not only help Tesla cut production costs, but also enhance vehicle performance by improving aerodynamics to compensate for a smaller battery pack. According to reports, the Model Q will feature an optional lithium iron phosphate battery in 2 capacity configurations, 53 kilowatt-hours and 75 kilowatt-hours. These configurations offer an impressive range of up to 500 kilometers or 310 miles, likely for the long-range AWD variant. Naturally, customers will have the option to choose between rear-wheel drive and all-wheel drive variants. Significant price differences between the variants are expected, with the top-tier model potentially reaching $35,000. At least, that's our perspective. Beyond affordability, Tesla aims to leverage its brand strength and technological advantages to lead in highly competitive markets. In China, where domestic brands like BYD dominate, the Model Q is expected to start at just 140,000 CNY, approximately $19,281, creating significant pressure on competitors. Initial production will take place at Gigafactory, Texas, targeting a rate of 10,000 units per week, with production expected to ramp up rapidly as Tesla expands to other facilities, such as Gigafactory Shanghai. If successful, the Model Q will not only be a formidable contender in the affordable EV segment, but also reinforce Tesla's leadership position in the global electric vehicle market. Now, let's talk a bit about the progress of the Tesla Semi program, which has seen some recent advancements. from its upcoming Nevada factory to its growing customer base. At the end of last December, Tesla's semi-factory in Nevada reached a significant milestone with the installation of the final large steel structure atop the main building. Additionally, Tesla Semi has gained a new customer, Saya LTL Freight, which has partnered with Tesla to introduce its first 2 Tesla Semi trucks into their fleet. Saya has praised the performance of the Tesla Semi, highlighting an energy consumption rate of just 1.73 kilowatt-hours per mile. The new customer also noted the truck's smooth acceleration, comfortable design, and ability to maintain speed on steep inclines, even under heavy loads. This feedback underscores the immense potential of the Tesla Semi in revolutionizing the freight and logistics industry.
As Elon wrote on X, compared to diesel, Tesla semi-trucks have a lot more acceleration, uphill power, and computer-controlled safety features like jackknifing protection, so both more fun and safer to drive. You may not know this, but the Semi has a significant edge when it comes to hill climbing ability, a feature that's rare in heavy-duty trucks. It can climb a 10% grade at 60 miles an hour even when fully loaded, which would be a nightmare for diesel. With its powerful triple-motor drivetrain, the Semi accelerates from 0 to 60 in only 20 seconds, even when carrying a full load. The Semi just outperforms traditional diesel trucks that often experience significant slowdowns on steep terrain and have to adjust power when carrying those heavy loads. We've seen many instances where diesels have tipped over just while trying to accelerate uphill, and that's kind of scary. As we've seen in a few videos, the Semi has the ability to outperform other trucks when going at high speeds on highways, even when climbing mountains. On these journeys, having surplus power can be an important feature for safety and comfort, allowing the driver to easily navigate challenging traffic situations and maintain a steady speed without encountering issues. The Semi's electric motor system provides instant torque and gets 1,500 horsepower that helps keep stable speeds and shortens travel times on hilly terrain. This advantage not only improves operational efficiency but also saves fuel costs and reduces wear and tear on the vehicle while making the driving experience more comfortable. Compared to diesel that consumes more fuel and struggles under the pressure of hill climbs, the Semi just delivers better performance while also cutting costs. It's particularly ideal for transport businesses that need to save time and expenses on difficult routes. The experience that makes Semi drivers excited also comes from its quieter operation, and in the near future, the Semi is going to be the safest truck in the world, as Elon confirmed that every Semi is going to be equipped with full self-driving. Diesel trucks are typically loud due to their internal combustion engine. The noise comes from mechanical components like your pistons, valves, and the whole fuel combustion process. Diesel can create significant noise, especially at high speeds or when carrying heavy loads. In contrast, the Semi uses an electric motor, eliminating the explosive noise from fuel combustion, making it a lot quieter. Electric vehicles only emit light noise from electronic components and the friction between the tires and the road, creating a quieter environment for the driver and reducing noise pollution around him. Traditional trucks often have a high drag coefficient, typically ranging from 0.6 to 0.7, meaning they require more energy to overcome air resistance when moving, leading to higher fuel consumption, especially at high speeds. The Tesla Semi boasts an impressive drag coefficient of just 0.22 that's much lower than that of diesel trucks, meaning that the Semi consumes less energy when driving at high speeds thanks to its aerodynamic design. Features like the smooth body design, closed grille, and other refined details minimize air resistance, leading to higher operational efficiency and reduced energy loss. Long-distance driving is a stressful job that needs intense focus. Drivers who are on the road for extended periods, especially on highways, are at risk of fatigue, sleep depth, and reduced reaction time. Lack of sleep is one of the leading causes of traffic accidents, and the recent semi-truck fire incident was believed to be caused by a driver nodding off. Long-haul driving is a stressful job that needs intense focus. Drivers who are on the road for long times, especially highways, often face sleep deprivation, fatigue, and slow reaction times. Lack of sleep is one of the main causes of traffic accidents. With its FSD, the Semi can help transportation companies optimize time and resources. The driver takes a break, the truck continues moving, reducing the required downtime and increasing the distance covered each day, which is especially crucial in supply chain when timely deliveries are essential. The Tesla Semi's fast charging time is another advantage that makes it reliable and worth buying. You might find this contradictory, given that no electric truck can match the refueling time of a diesel truck, but let us explain. While it takes longer to charge the semi's massive 10,000-pound battery pack compared to filling up a diesel truck's tank, the key point is that Tesla Semi only takes about 40 minutes to fully charge, allowing drivers to charge the truck while unloading cargo or taking their required breaks. It's been quite a while since Elon Musk introduced a new battery tech for Tesla EVs, with the last major update being the 4680 at the end of 2020. That's why 2025 could be the perfect time for a new battery release, and there are already hints of it. As we know, aside from Tesla's self-produced 4680s and those supplied by Panasonic, all other batteries like the LFPs are provided by CATL. So the next battery pack for Tesla could very well be something revolutionary. It's not just about power. What makes this battery wild is that it's a new type, rare on the market. With an energy density of 500 watt-hours a kilo, the range for EVs could be incredible, and it won't be long before the 4680 is no longer Tesla's top battery. So what is this new battery, and which Tesla models will CATL be putting it in? CATL is the world's largest battery manufacturer and it's got a very strong relationship with Tesla. But we don't think they're considered the biggest just because of their scale. CATL's truly a pioneer in new battery technologies, with some of the best engineers in the world. Whenever they announce a new battery technology, they consistently deliver on their promises. They don't make empty claims. They don't say, "We're working on this battery," only for it to go nowhere or drag on for decades. So yeah, it's pretty refreshing to see a company that doesn't overhype or mislead us. This time, CATL is placing its bet on solid-state batteries. No longer just a concept on paper, they've already entered the trial production stage, meaning they're producing small batches before scaling up to mass production. Here's an interesting fact about solid-state batteries. This isn't exactly a new technology. Research into them began over a decade ago alongside with other battery types, but the reason they're now considered cutting-edge is simply that few manufacturers have managed to actually make them successfully. Only a handful of companies have real tangible solid-state batteries, or packs, but that's not even the most interesting thing. There's a bit of awkward truth here for Toyota. The automaker often gets talked about, compared, even criticized every time another company succeeds with solid-state batteries. It happened with QuantumScape, and now it's CATL's turn. The reason is simple. Toyota has repeatedly made bold claims that its 2 generations of solid states would help regain its position and deliver a breakthrough in EVs with this tech. If you're curious about Toyota's ambitions with solid-state batteries, their performance, and projected plans, we've covered all the details in our previous episode. You can click on the video currently displayed on your screen to check it out. Back to CATL's solid-state battery. Just like many other times, this is a technology that's pretty easy to understand. You just need to know that solid-state batteries is still a type of lithium battery, quite similar to those used in EVs today. Big difference is that solid states use a salt electrolyte instead of a liquid or gel electrolytes that we see in lithium-ion batteries for EVs. To replace the liquid electrolyte in traditional lithium-ion batteries, solid ones typically use solid oxides, oxide polymers, and sulfides as conductive materials. CATL's chosen sulfide for their solid-state battery because this is the most suitable and efficient electrolyte for this application. The first major advantage of most solid states is their higher energy density compared to any other type of battery out there. So far, Toyota's a solid-state battery manufacturer, boasting an energy density of around 600 watt-hours a kilo. However, as we mentioned, this target may still be a ways off for Toyota. On the other hand, CATL's solid-state batteries can currently reach an energy density of up to 500 watt-hours a kilo. While this is new info to us, it doesn't raise that many doubts, as CATL has already had its condensed battery technology with an energy density of 400 watt-hours a kg. Initially intended for aviation, this technology will soon be adapted for electric vehicles in the next few years. According to CATL, with an energy density of 500 watt-hours a kilo, this number is about 40% higher than current battery technologies. For comparison, lithium iron phosphate batteries, a popular choice that Tesla likes to use for Model 3 and Model Y, have an energy density ranging from 150 to 160 watt-hours a kilo. With 500 watt-hours a kilo, the performance would be 3 times higher. When we look at a better example, Tesla's current 4680 has an energy density of around 272 watt-hours a kilo, meaning CATL's solid-state battery would nearly double the density of the 4680. And that's exactly why we confidently say that the 4680 will no longer be Tesla's best battery once Elon adds solid-state tech to this lineup. We're not sure if you know about this, but with any battery that has a higher energy density, it means they deliver more energy while being lighter and more compact. This is a breakthrough for electric vehicles as it helps increase range and reduce vehicle weight. Let's make it simple. If you keep the 81 kilowatt-hour battery size in your Model Y, but replace it with CATL's solid state, the driving range would increase to around 450 kilometers, even up to 800. That sounds hard to believe, but it's clearly possible when we've got a higher energy density battery that's also lighter. This is what Elon has been searching for years but hasn't found yet. However, it's important to note that Tesla won't just switch to solid states without adjusting other factors. The cost of the batteries has never been cheap, and this is a reality we gotta face. The production costs can sometimes be twice as high as regular lithium-ion batteries. For example, the cost of sulfide, the potential material that CATL's chosen for their solid-state batteries, is 5 times more costly than lithium carbonate. So, a solid-state battery for an electric vehicle, which will likely be smaller than usual to balance performance with cost. The most reasonable hypothesis is that CATL solid states will be the first integrated with more expensive luxury electric vehicles. If they do make their way to Tesla, it's likely that Model S and X will be their first to feature these batteries. A local Chinese media outlet known as Late Post reported CATL's R&D team has over 1,000 people working on solid-state batteries, and they're focusing on experimental solid-state sulfide batteries. However, instead of producing large-capacity solid-state battery cells, CATL has started trial production of 20 amp-hour capacity cells. You may not know this, but CATL currently holds some of the fastest charging batteries in the world. They've been recognized for their Shenxing battery, the first to achieve a 4C charging rate, and have since been continued to improve with the Shenxing Plus versions. It's so fast that by the time you finish a cup of coffee, the battery could be nearly fully charged. According to their website, with the Shenxing battery, it can give a driving range of 400 kilometers with a 10-minute charge and over 700 kilometers on a full charge. Yeah, on the screen is a video about Shenxing Plus, also known as LFP Battery Gen 3, which we also covered in a previous episode. If you want to learn more about it, we believe there's a lot of useful information here. Now, back to the topic. It's hard to argue that a premium battery like the solid state could achieve such a short charging time. For solid states, charging from 10 to 80% could take 10 minutes or even less because, as we mentioned, solid-state battery pack could be smaller when integrated into EVs. Ultimately, the charging time for these batteries would be comparable to the refueling of an internal combustion engine car. Part of the reason for this is that solids electrolyte in solid-state batteries, especially the sulfide that CATL uses. This material's got a high ion conductivity, which helps speed up the lithium-ion transport process, accelerating the charging process. Plus, liquid electrolytes can be negatively impacted by high temps during charging, and that can cause dendrite formation, these sharp, needle-like structures that shorten the battery's life and cause short circuits. However, sources from CATL indicate that the charging speed and cycle life factors that affect battery longevity still need improvement, meaning that solid-state batteries are not yet perfect. For Tesla's 4680 battery, it takes around 35 to 40 minutes to charge from 10 to 80%, and we think that's okay. But if they could bring that time down to just 20 minutes, that'd be a big upgrade. After all, no one wants to wait too long at the charging station. With the advantage of the materials and structure, charging time's never been a challenge for any solid-state battery, and it certainly won't be for a company like CATL's vast experience in fast charging tech. So, when CATL solid states are officially integrated into EVs, charging speed will be like a monster. We're betting on that. Many of CATL's new batteries are reported to be used in Tesla once they pass the research phase. However, as we've mentioned earlier, even though CATL's known for optimizing production costs and efficiency, this does not mean that all their batteries are going to be cheap from the get-go. No, they won't be affordable initially. It's rare for any new tech to be cheap right out the gate. The company has used a 1 to 9 scale to assess the maturity of their technology and manufacturing processes, positioning themselves at level 4 at the time. Moreover, their goal is to reach levels 7 to 8 by 2027, indicating the feasibility of small-scale mass production. However, large-scale production is still expected to be limited by costs and other tech challenges, so we'll likely see solid states in high-end EVs sometime in late 2027 or early 2028. If CATL manages to overcome the challenge of cost and technical issues, the next step will be to integrate their solid-state technology into a larger battery pack and scale up production. This remains a significant challenge, but clearly their batteries do very well, and CATL's been making progress quite quickly. CATL CEO Robin Zhang believes that the best battery technology is already on the market, and he feels Toyota's exaggerated claims about solid states are making false hope after years of research with no real results. He says Toyota's statements are mythical. However, this does not mean that CATL's CEO underestimates solid-state technology. Thanks for watching our video. If you found the content helpful and want to explore more exciting info about Tesla EVs, don't forget to hit the like button and share this video. Also, make sure you subscribe to our channel and turn on notifications so you never miss out on our latest videos. We appreciate your support and look forward to seeing you in the next video.